Have you ever stopped to think about the apps you use every day? The massive, complex ones. We're talking social media, banking apps, you name it. How on earth are they built by huge teams without just completely falling apart? Well, it's not magic. It's actually a really clever set of secret rules, and today, we're going to pull back the curtain.
I mean, seriously, think about it for a second. You've got maybe hundreds, even thousands of engineers, all working on millions of lines of code. How does it all stay organized? How do you stop one person's tiny mistake from bringing the whole system crashing down? It seems impossible, right?
Well, the secret, and it's a brilliant one, is a concept that actually mirrors the real world. It all comes down to starting with a solid plan, a blueprint, if you will, and then enforcing just a few really simple, non-negotiable rules about how everything is allowed to interact. So, let's break it down.
Okay, so to really get how software stays organized, we first have to get our heads around the difference between a plan and the actual thing you build from that plan. This is going to be our main analogy for today.
So, in the world of code, we call that blueprint a class. It's the master design. It's the piece of paper that says, okay, any house we build is going to have doors, windows, and a roof. But here's the key. The blueprint itself isn't a house, right? You can't live in it. The actual house, the thing you can paint and live in, we call that an object. And the coolest part? From that one single blueprint, you can build thousands of different houses or objects.
All right, so we've got our blueprints and our buildings. That makes sense. But why all the rules? Well, let's put this idea to the test with a challenge. Let's try to build a digital university system. In our digital university, we're going to need blueprints, classes for all the important stuff. We'll need a blueprint for what a student is, another one for an instructor, and one for a course. Then, from those blueprints, we can start creating our actual individual student objects, instructor objects, and so on.
And here is where the chaos could kick in. See, without any rules, any part of our system could just reach in and mess with any other part. A student object could just change its own grades. An instructor could go modify the university's financial records. It would be an absolute free-for-all, a total mess. And that is exactly why we need access rules.
And this brings us to the 3 secret rules that keep everything safe and sound. You can think of them as different security levels for all the information inside our blueprints. First up is the most open one, public. This is pretty much the default setting. If something is public, it's like shouting it from the rooftops. Any other part of the code, anywhere in the system, can see it and use it. No restrictions.
A good way to think about this is your home's address or your mailbox. It's information that's meant to be seen by the outside world. There's no security around it because, well, it's not sensitive. It's public knowledge. Now, on the complete opposite end of the spectrum, we have private. This is maximum security, Fort Knox. When a piece of information is marked as private, it is completely and totally locked down. It can only be seen or changed by code that lives inside that very same blueprint. Nothing else can touch it.
This is the equivalent of your personal diary or maybe your bank account PIN. You would never want other random parts of an application, let alone other people, to have direct access to that. It is for internal use only, period.
So somewhere between wide open and totally secret, we have this really interesting middle ground, protected. Protected information is hidden from the outside world, just like private stuff. But it makes a special exception for any child blueprints that are based on the original one. It's like a family secret.
Think about the toolbox in your garage. You don't want the general public just walking in and using your tools, right? Of course not. But your family members? Yeah, they're allowed in. In programming, we have a similar idea where a child class is part of the same family as its parent, so it's trusted with access to these protected, family-only resources.
And this table here just lays it all out perfectly. You can see public is a yes all the way across. Everyone can see it. Then look at private. A yes only for inside its own class, and a big no for everyone else. And right there in the middle is protected. It's available to itself and its children, but not to the outside world. Okay, so far, everything we've talked about belongs to the individual objects, to our individual houses. But what happens when we need to track something about the whole neighborhood? This is our next puzzle. For example, how do we track the total number of students enrolled in the entire university? If we give each student object its own counter, each one would just say 1. That doesn't really help us, does it? We need a single shared counter that belongs to the whole group. And this is where the static keyword comes to the rescue. A static property is different. It's not attached to each individual building.
Instead, it's attached directly to the master blueprint, to the class itself. It's one piece of information that is shared by every single object created from that blueprint. So here's how that plays out. We create a single counter. Let's call it total students, and we put it on the main student blueprint. It starts at 0. Now, when the first student object, Hamza, is created, boom, the blueprint's counter ticks up to 1. Then another student, Ali, is created, and that exact same shared counter ticks up to 2. It's a single source of truth for the entire group.
Okay, time to bring it all home. Let's see how these rules, public, protected, private, and static, come together to build us a secure, organized, and functional digital university.
So let's look at a single student object. Their name? That's public. We want other systems to be able to see who the student is. Their student ID, though, maybe that's protected. That way, closely related systems, like the library or housing, can access it, but it's not just out there for everyone. And most importantly, their grades are private. The only way a grade can be changed is by using a controlled, secure function inside the student object itself. No one can just reach in and change it.
So, when you boil it all down, it's actually pretty elegant. We use classes as the blueprints to create our actual objects. We use those visibility rules, public, protected, and private, as a security system to stop chaos from breaking out. And we use static members to keep track of information that's shared across an entire group.
And here's the really cool part. This isn't just about code. These same patterns of public information, of private secrets, and of shared, protected family knowledge, they're everywhere. You'll see them in how companies are structured, how governments work, even in our own personal lives. Once you start looking for this pattern, you really can't unsee it. Thanks for watching.